And we'll finish, last but not the least, right? We'll finish with Antoine and Tristan from Escape, right? The rising star of API security and GraphQL, graduated from Y Combinator, raised their seed round, just got like a trophy from Les Assises, right?
Absolutely. Yeah, exactly.
One of the top security conference in Europe, right? I don't know if we can say it's the DEF CON of Europe or the Black Hat, because it's more enterprisey, a lot more enterprisey.
Yes, absolutely.
It's the RSA. Let's call it the RSA of Europe.
Yeah,
right?
Absolutely. This is exactly that.
That's fun.
Yeah.
So congrats, and you had a great study on GraphQL vulnerabilities. So let's dive into that, and you have some time for that. So yeah.
Great. Thank you, Mehdi, for having us. Glad to be here today or tonight, depending on where you are in the world. We are Escape, and we are here to present a study about GraphQL vulnerabilities in the wild. So with a powerful language comes great responsibility, and in particular, the responsibility of securing it. And we did a huge study of scanning real-life production GraphQL applications on the internet, online. And we're here to present what we found and what it told us about securing GraphQL in production. So let's start and let's dig into that. First, a little bit about Escape. We are a company. We are the first automated security testing platform that is actually able to test the business logic of APIs, and more specifically of GraphQL, because we started with this technology, which we like a lot. So for this study, we scanned more than 1,500 production APIs for trying to finding security vulnerabilities. It took us more than 400 cumulative scan hours. So that's a huge AWS bill that we have for producing this study. I hope you will like it. And we found a lot of vulnerabilities. We found more than 46,000 security alerts on the production GraphQL endpoints. That's more than 30 security alerts per GraphQL app on average. So we can see there is a huge security problem in the production GraphQL apps. The result of the study has been published on a full featured report, which is called the State of GraphQL Security. If you want to check it out to have like the full statistics and the full results, you can feel free to check it out. I'm Tristan. I'm the co-founder and CEO of the company, and I'm here tonight with Antoine, my co-founder and CTO, and he handles the tech and product part of the company. And I will let him start by explaining why GraphQL is specifically vulnerable to cyber attacks in production.
Thank you very much, Tristan. So yes, as you mentioned, as a CTO, I'm here to handle the technical stuff here. So let's start with technical things. So the first thing that is really important to understand here is why is GraphQL so vulnerable? The first thing is that GraphQL is currently used in production by companies in every Fortune 500 verticals, in retail, finance, travel, and so on. And mainly thanks to its amazing federation capabilities that allows it to combine multiple API sources together, from whether they are from REST, GraphQL, or other kind of APIs. GraphQL indeed is an amazing language, but with great features comes great responsibilities. And indeed, in that case, every single of those features that are in this slide, such as operations, fields, directives, parameterization, and so on, they also come with a potential source. They are also potential source of vulnerabilities for GraphQL, of course. In addition, GraphQL is a graph which is connecting resources together. In particular, one resource can be accessed by an unlimited number of different paths in the graph, which make access control very, very difficult to ensure and to manage in GraphQL application. Okay. So the second thing that is really important to understand how we came to this report is how did we manage to get all of this data from GraphQL endpoints? And why is it hard to automatically assess GraphQL APIs from a security point of view? Okay, so if we just send random cybersecurity payloads on APIs, obviously the request won't pass the validation layer, and therefore we could not test any business logic of the API, and especially from a cybersecurity standpoint, this will make nonsense. That's why we developed a unique technology, which is called feedback-driven API exploration, which is able to generate legitimate traffic on GraphQL APIs. It does not require any agent nor traffic capture, and thus it does not endanger the production data of the customers. Well, to illustrate this, let's take the example of an e-commerce platform with two kinds of users. Imagine you have, obviously, on an e-commerce platform, the sellers on the one side, that on the one hand, that should be able to see the orders of all the customers and interact with those orders. And on the other side, you have buyers that can make orders, but that are not allowed to see, obviously, the orders of other buyers. To test a complex business logic case like this, it requires that the application we test has at least one seller, two buyers, one product for sale, and two pending orders from different buyers. And with our unique feedback-driven API exploration algorithm, we are able to generate the legitimate sequences of requests that can test the situation every time the application is updated by the developers. The second trick here is that, again, GraphQL is a graph. So the algorithm must ensure that we test this condition for all the path and for every single path in the GraphQL application. All right, so have we done with the pure technical part that was, I think, necessary to understand the results that we are going to introduce now? So what did we find? Actually, we find almost 50,000 vulnerabilities into the wild. What is really interesting is that 10% of them actually were of critical severity, whereas we made all of those requests completely on an unauthenticated manner, and everything was accessible on the internet. So here we created a custom alert classification that is tailor-made for GraphQL ecosystem. But here is the matching with the OWASP top 10 23 vulnerabilities. And very interestingly, we can see three main categories of vulnerabilities emerging here according to the OWASP top 10 classification. And this is what Tristan is going to explore now with you. Thank you.
Thank you, Antoine. So what we can observe first, if we take a deep dive into the result, if we break them down per classification of the findings, is that a lot of alerts that we found on those results are GraphQL specific. So actually the most common vulnerabilities in this study, the most common security alerts are specific to GraphQL. Let's take a look at the chart. So here is a chart of the amount of alerts with respect to the type of vulnerability that we found. And we can see that the three most common vulnerabilities that we found on GraphQL endpoints are all related to GraphQL specific features and features of the GraphQL language or features of the GraphQL engines themselves. The first one is RDS limits. It's like a complexity problem. The second one is directive overloading. It's like a denial of service that is caused by abusing the engine's parser. And the third one is information disclosure through field suggestion. And even in the rest of the vulnerabilities, we can see that a lot of them are also specific to GraphQL and cause denial of service, complexity problems, pagination problems, and so on. So let's take a deep dive into the three most common vulnerabilities in GraphQL endpoints, in production GraphQL endpoints, and let's take a look at why they happen and how to prevent them. The first vulnerability is like the ability to brute force an GraphQL endpoint using batching or aliasing. Batching or aliasing are two different features that have the same goal in GraphQL. They allow to batch and to launch several GraphQL queries or mutation, several GraphQL operations in the same HTTP call. So they can be used, for instance, to query three different three different users at the same time, or three different queries that have nothing to do with each other in a single HTTP call, and then get faster performance. But the problem with this feature is that if it's not limited, it can allow to bypass the rate limiting that is done at the HTTP level. So, for instance, say you limit you rate limit the login to 10 requests, and then you stop it. With the batching activated or the aliasing activated, you can actually send as many login requests as you want with different usernames and different passwords, and just bypass the rate limiting and try to brute force actually the login mutation and get the password and the token of an user. So this is a very simple use case that highlights how GraphQL is different from classic APIs from a security point of view, and why it can be exploited in tricky ways to find security vulnerabilities inside of an API. The second one is denial of service. It's a denial of service through fragments. Fragments are a piece of logic that can be shared between multiple queries. It's like a function, but in the GraphQL language. So for instance, here, in this case, we create a fragment name parts on the object person, and that returns its first name and its last name. But what happens if we create fragments that call each other in a recursive manner? Well, actually, some GraphQL engines are vulnerable to it and create an infinite recursive loop that end up crashing the server. So in this case, for instance, it's a Node.js server that is vulnerable to this, and we created this recursive fragment. We sent it to the server, and we were able to crash it completely. The problem with this is that it relies on the GraphQL parser itself, and it's very hard to fix because it does not depend on the custom code of your developers, but rather on the engine itself. So you have to wait for an update of the engine that would fix this problem in order to fix the vulnerability and to not be vulnerable anymore. And the last one that I wanted to highlight is the internal API schema leak. So as you know, GraphQL has a feature called introspection, and this feature allows you to fetch the full GraphQL schema by sending a specific query to the GraphQL endpoint. In specific cases, you do not want to disclose the full schema because it's not meant to be public, and you want to preserve the secret of what lies in your GraphQL API, so you can deactivate introspection. But there is another specific feature in GraphQL that is implemented in most GraphQL engines. It's called field suggestion. Basically, when you do a query with a typo on a field name, the GraphQL engine sends you back an error message that says, okay, did you mean this or that? The problem with this handy autocomplete feature is it can be used to build back the schema by sending approximate or random possible fields and letting the engine tell you what is actually inside of the schema. So this is an example of a real-life situation that we encountered with Escape of a company that closed its schema, but let the field suggestion feature enabled. And we were able, using an open source tool called Clairvoyance, to fully build back the internal schema of the application. And guess what? They had an update admin mutation that was, they thought it was hidden, so they didn't protect it against authorization. So we were actually able to change the admin password of the platform just by uncovering the full schema of the application, including the mutations. So this shows an extreme case, obviously, because this is a high or a critical vulnerability. But this shows a practical use case of how to exploit simple features of GraphQL in order to escalate to large-scale attacks. Okay, so we reviewed the vulnerabilities that are specific to GraphQL, but we must not overlook the classic API vulnerabilities because they are still there in our study. So if we take a quick look, we can see that there are a lot of server errors that disclose too much information, stack traceback with a lot of details, and also access control problems, and even some injections or IDORs. So again, access control problems that allow to fetch a lot of data from the API that are exploitable in the wild. So there are still injections, SQL injections, server-side request forgery, and even one bash command injection that are exploitable in the wild on GraphQL APIs. You found injections where I think of the past, apparently it's not. If we take a closer look and a deeper look at what really happens for those specific vulnerabilities, we can see that a lot of endpoints are vulnerable to API errors and information disclosure. So in a lot of cases, the GraphQL server, when it has an error, it sends back a stack trace, which includes the position on the code where the error lies. And this gives a lot of information about the internal libraries that are used by this server. And then it's pretty easy to go into online databases and find the vulnerabilities that are specific to those internal libraries and try to exploit them. So in this case, we can see that this problem shows that this server is using Apollo Gateway 0.6.1. And we can see that this version of Apollo Gateway is critically vulnerable. And we could exploit this in production. Second problem, access control issues. I can't name how many access control issues we saw during this study. There are a lot of endpoints that actually have mutations to update different sensitive data in the database that do not need any authentication token. It means that any user, any public user, unauthenticated, can change actually the state of the database and make complex operations within the API. So this is a huge problem also that must not be overlooked. And finally, as I said, injections are still there. So we found 16 SQL or no SQL injections during this study. So simply injections in GraphQL parameters that were not escaped properly. You see escaped, it's the name of a company. Everything makes sense, right? So 16 SQL and no SQL injections because the parameter were not escaped properly, and one bash command injection on a GraphQL API, and 3 server-side request forgery. So for avoiding this, you must be sure that you validate the input properly and that you escape any sensitive character or special character in the user input. Okay, last part of those results is the sensitive data that we found that was public in those GraphQL APIs. So GraphQL, again, with introspection, has this specificity of letting an automated crawler like Escape and the technology of feedback-driven exploration that we build explore the API and index the data that is publicly available. So we use this technique and we used it on all the different endpoints to see if we could get sensitive data from the endpoint. We found more than 4,000, almost 4,500 potential PII and sensitive token secrets leaks in those GraphQL API. If we take a closer look, there is a lot of PII involved, a lot of emails, and a lot of phone numbers. Of course, some of them might be legit. For instance, if it's a support phone number or a support email, it can be legit to have it publicly, but the amount is so huge that we're pretty sure that most of them should not be there. Even worse, we found password numbers, US bank account numbers, international bank account numbers. So we found all those data that was publicly accessible to any client on the internet that was willing to put time enough to search in the GraphQL API. And about the token, it's even worse. We found API keys, hashed passwords, unhashed passwords, like plain text passwords, AWS tokens, Adobe client, Asana client IDs, GCP API keys, Slack tokens, and even OpenAI tokens. So we found OpenAI tokens in error messages that were sent back to the client when there was a problem within the API. So it means there is a huge lack of best practices when it comes to stripping the secrets from the error messages and from the response of the APIs. And this also must be taken care of. Okay, let's make a pause. Now, if we take a look at this study from the OWASP top 10, the OWASP API top 10 framework, we can see that in GraphQL, there are a lot of denial of service and complexity issues. So GraphQL is a language, it's a graph, it's prone to unrestricted resource consumption by default. You must limit the resource consumption by the GraphQL queries and ensure nobody can exploit the GraphQL specific features to create denial of service or overcharge the server. The second thing is access control, authentication, and authorization. So again, GraphQL is a graph. It has a graph nature, and access control in a graph is very complicated because you need to secure all the paths leading to a sensitive resource if you want to be sure it's secured. So we have seen a lot of broken object level authorization, as well as broken authentication systems, broken object property level authorization, broken function level authorization. We have seen a lot of those, and they are generally critical, and especially the last two ones. And finally, security misconfiguration and information disclosure are done because GraphQL is very verbose by default when it comes to error messages. It sends a lot of data back. It can send internal error messages from underlying APIs. It can send data that is in the cache. It can send data that shows what is the internal schema of GraphQL using development features that are enabled in production. So security misconfigurations are very common, mostly because the best practices are not well spread among the GraphQL developers yet. And we advocate for more best practices for that matter. Okay, so in conclusion of what we found during this study, we found 130K plus public GraphQL APIs into the wild by scanning the whole internet. And we scanned more than 1,500 of them for security vulnerabilities, the ones that were public and unauthenticated. We highlighted numerous vulnerabilities in GraphQL, most frequently GraphQL specific, but also more classic, such as injections, error messages problems, and so on. And we found a lot of access control flows and secret leaks, which are very frequent in GraphQL when you take a wide look, a macro look at what exists on the internet. Okay, so again, if you want to take a look at the details of this report, and especially all the figures and all the different vulnerabilities that we found, you can take a look at the State of GraphQL Security 2023. It's free to download, so feel free to check it out. And now we can talk about two more things that are important to us and that are complementary, we believe, to this study. During the talk, I mentioned that the vulnerabilities from GraphQL came mostly from two different things. One, it is the lack of proper security configuration. So security misconfigurations are responsible for a lot of GraphQL vulnerabilities that we found. And the second thing is the lack of best practices and the lack of knowledge about the best practices from the GraphQL developers. So we have a few things about this that we'd like to talk about. But perhaps I will let Antoine, because this is his part of the force.
Yeah, no, absolutely, Tristan. What I think it's really interesting to mention here is that this study has been made on production-ready GraphQL endpoints that are owned by, I would say, companies with good reputations. And what is really interesting here is that the different best practices Tristan mentions, the vulnerabilities we found, and so on, actually the responsibility of securing this falls into the developer's hands. And we really found there was a huge lack of tooling for developers to handle GraphQL vulnerabilities at scale. And this is why we worked on 2 open source projects that are absolutely interesting and that help developers fixing vulnerabilities in production, in their production applications. The first one, is GraphQL Armor. This is a completely free and open source security middleware, and we will love you to contribute. And it provides out of the box security best practices for some of the vulnerabilities we presented before, and especially the GraphQL specific vulnerabilities that are related to denial of service and complexity attacks, such as the one that are described here. So maybe Tristan, you want to add a few words on GraphQL Armor?
Yeah. So GraphQL Armor is like I think like it's like the missing piece of GraphQL security middlewares. So we decided to build it because we saw how frequent it was misconfiguration, how frequent misconfigurations, and especially security misconfigurations were in GraphQL. And very quickly we were able to gather developers from the different major GraphQL engines. So it's specific on Node.js or TypeScript engines, but we can see that the Guild decided to come into the journey to help us build GraphQL Armor. Apollo themselves, they decided to come with us and help us build GraphQL Armor and make it compatible with the last version of their engine. So we have really gathered the community around this open source middleware, and we quickly have made it adopted among great organizations. So it's very cool to see the community gathering around security. And the good thing is with GraphQL Armor is that it doesn't impact production. It's designed to be completely seamless for integrating into production and never block legitimate traffic, but just block requests that are obviously abusive, and especially the ones that abuse by sending too many aliases, by sending too many characters, by exploiting requests that are too costly, too deep, and that use too many directives. And of course, we also block the field suggestion, because in this way, if you deactivate the introspection, your GraphQL endpoint will not leak the actual GraphQL schema of your API. So again, if you are using Node.js with GraphQL or TypeScript with GraphQL, feel free to use GraphQL Armor. We really encourage you to try it. It's very efficient, very easy to use. And also feel free to contribute to the repository because we always want to collaborate with the community. So that is
it's a quite active repository, and we just had a great merge request today from Redwood.js maintainers.
Yeah.
So we are quite happy with that, and GraphQL Armor is now downloaded more than 50,000 times a week. So that's cool for a spare project.
Yeah, originally it was a side project that we decided to build in 2 weeks with our engineering team, and it just it just made it through. So that is for the first open source project that we wanted to talk about, and the second one is we're introducing the Learning Center. So this is for the learning best practices part. So we're introducing escape.tech/learn, which is a learning center for understanding and practicing the security best practices for GraphQL. It gathers actually lessons from the study that we showed today. So the different vulnerabilities that are more common and how to avoid them with interactive training that happen everything in the browser. So no need to install in development environment. You can just
web containers.
Play, exactly, with web containers. So it's very it's a nice piece of technology actually, and you can just go and try to play with it. It's very relevant, very useful, and we are adding new courses on a weekly basis. so it will be updated constantly. And we are quite proud of the results so far, and we're looking forward to see you compete for the maximum of points in securing GraphQL. I don't know if you want to add something, Antoine.
Well, actually, again, the project is fully open source. The project is in beta too, and we just released it in beta version. So feel free to open issues on GitHub, and we'll love to improve the project and to make it evolve with the community.
Great. Okay. I hope you liked it. This is the end of the presentation. I will just let the slide. Can I do it?
Yes.
Before we move on, I will just let one last time the QR code for having the full report. If this is interesting for something, I received notification because I see that there are a lot of downloads of it. So I'm glad that you like it, and I will be happy to answer the questions from Mehdi and others.
Totally.
Yeah, thank you very much. A lot of things actually. When we read your report, I have a question for you. Like, after 8 years of GraphQL, it seems the adopters are not completely ready, or at least they're still doing a lot of mistakes. Do you think it's because GraphQL is behind its apparent how can I say that? It seems easy to use, it's easy to consume, it seems easy to build, but actually it has complexity over time that people may not see? Or do you think it's the tooling, or do you think it's just security, people don't get it? Right? Why so many questions?
It's definitely
I would say it's the last one. I think there is a lot of different things here. I think one of the things is not only that the security people didn't get it, but the bad guys also didn't get it and didn't know how to use GraphQL and how to exploit the specificities of GraphQL. But this is changing, and this is changing fast. We have seen a lot of projects on GitHub that are dedicated to exploiting the vulnerabilities of GraphQL. During this talk, I've mentioned Clairvoyance, but there is also GraphRoof, there is also GraphQL Cub. There are a lot of open source projects that are dedicated to actually exploiting GraphQL. So the security people inside of the companies, and especially enterprise, they are starting to realize that GraphQL is actually a weak point, and that the bad guys are actually starting to notice they can exploit it. So this is why the community in general is getting more and more aware of the best practices and willing to implement them in their production endpoints.
And as mentioned in the pitch earlier, the pitch just before ours, GraphQL is gaining ground. So there are more and more GraphQL used in enterprise companies. So it becomes more and more interesting to try to hack it too.
So bigger companies, so bigger pot. So then attackers begins to be interested by GraphQL. So, okay, more GraphQL, let's say, influence. So more people interested to know what's behind, right? Okay.
Absolutely. It's like more people are having Macintosh. So there are more and more viruses on Macintosh too, compared to how it was 15 years ago.
Yeah, I understand. I totally understand. So it's not about the tech. It's more about like the incentives. It's an incentive problem.
Yes, but there are so few things about the tech due to the fact that GraphQL is a graph, and this causes a lot of access control. This is a nightmare to ensure access control in GraphQL because of this reason that one resource can be accessed by an unlimited number of paths and of deep path, I would say. So it's quite complex to secure too in practice.
You cannot have the good advantage of being a graph and without the bad advantage of being a graph, or the disadvantage of being a graph, right? So totally, totally agree. So do you also see a difference in maturity of companies, like in your report and in your customer base? Like, are more mature companies using GraphQL better than the smaller one, or no? Like we see exactly the same.
I would say that the early adopters of GraphQL start to do well, especially the big organizations that adopted GraphQL early. They generally do better. I'm thinking about GitHub here. Stripe. But even if they do better, they still have a lot of security flaws that they didn't find. So they do better, but they still do not understand to which extent GraphQL is actually exploitable.
Yeah, I remember also other company like Dropbox or Netflix who were using GraphQL like really early 2016 or something.
Yes.
Yeah. Again, coming at API Days to talk about it. So yeah, like top American players, large companies have been, Airbnb also, I remember. So all these companies have been using it for really a long time, right? So do you think the tooling ecosystem, except for Escape, right? But do you think the tooling ecosystem is mature enough? Where are there opportunities today to build great GraphQL tooling?
That's a great question. It's a great question. I see the tooling maturing very quickly. Especially, I want to give kudos to a friend from the guild on that matter.
Yes.
They are gathering the community around the project of creating better open source tooling for GraphQL. They're on the verge of succeeding. There is a lot of good stuff coming out of their code bases. And so they're building a lot of exciting stuff, and we're glad to give them a hand sometimes. And so I think like the tooling is evolving very fast. And since we started Escape, a lot of other tools for the GraphQL ecosystem have evolved a lot.
Yeah, we can see that Postman released a GraphQL engine for Postman very recently. So it's evolving. However, we can see that GraphQL still lacks of some toolings for developers, such as it is still really poor from a monitoring point of view. If you don't use, for example, the default Apple solution, I'm thinking about Datadog APM, for example, which is not really handling GraphQL requests and so on. So there is still a lot of work to do on the GraphQL ecosystem, and companies that are building the tooling are currently realizing that GraphQL is becoming a priority for them. And we see a huge motion towards GraphQL in the last month, I would say even.
Yeah.
Okay, so it's even in terms of weeks you see adoption.
Yes,
there is a huge difference, and I've talked with people from monitoring companies that were telling me like 1 year ago or 2 years ago we had about 3% of companies using GraphQL, and now it's 25%. So the growth is tremendous and continuous, and we're glad about that, because we think GraphQL is a great technology that has a lot to offer to engineering teams.
Okay, thank you very much. So it seems we don't have any more questions, but yeah, thank you. And again, if you can put again the QR codes for people to be able to download the report. So you will I don't know if you will do this report every year, but how we can contribute to the next report?
Well, this is a great question. I think you can submit your API to be tested as well.
Yeah, that's it.
If you dare about putting your API to be tested, but as well, like feel free to contribute to the open source project. This is really what helps the community, and especially the GraphQL community, to thrive.
Perfect. Thank you very much, Antoine. Thank you, Tristan. And thank you for closing this GraphQL segment by production-ready GraphQL, and your great report on security issues, at least that you found, and so many others to be found.
Absolutely.
The Escape guys are coming. Oh no, they will find.
We are sure. Thank you, Mehdi, for having us today.
Thanks a lot, Mehdi. Thanks a lot, everyone. Thank you.
Have a good one.